Thank you very much. So everyone, what's the future of grid storage batteries? What actually is a grid storage battery? I'm going to get to that, but first of all, I want to touch on the shortcomings with lithium-ion batteries. Now we know that there's fires and explosions because of the thermal runaway with the liquid electrolyte. We know lithium-ion batteries are limited in their use from about 15 degrees to 35 degrees. They're not suitable for very, very cold climates, and they're not suitable for very, very hot climates. They also have limited lifespans because of the degradation issues that lithium faces, just like your mobile phones. They're limited in their use. They're basically 7 years. And we know that they use a lot of critical materials. They're using lithium, they're using copper, they're using cobalt, they're using graphite, and they're using manganese. They're subject to the supply chains. So what if I was to tell you that there was a battery technology that was completely fire and explosion proof, that lasted for more than 15 years and could operate in a wide range of temperatures, didn't use any lithium, copper, cobalt, graphite, or manganese? Can you believe that? This is Altech's product. It's the Serenergy sodium chloride solid state battery. Sodium chloride being common table salt. So it's a salt and nickel battery technology. And it was developed by Altech's R&D partner and joint venture partner, which is Fraunhofer. Now, Fraunhofer are German-based. They're a government institute. They're one of the world leaders in research and development, and they've spent 8 years developing this technology. Now, the good thing about these batteries is because they're solid state, they're completely fire and explosion proof. They're also able to be worked in a wide range of temperatures. They can be taken from -40 to +60 degrees. We can take this battery all around the world. We're not subject to temperature conditions. This can operate anywhere. They also have a very large life of over 15 years. Sodium doesn't degrade like lithium does, so they have a much longer life. Now I'll talk about the chemistry about how this battery works. So what we have is a ceramic solid state electrolyte, which is why these don't catch on fire. Inside of that we have a positive nickel rod, which acts as the positive terminal for the battery. We then put sodium chloride and nickel powder inside of that electrolyte, and that whole thing sits inside a stainless steel canister. That is a 250 watt capacity cell. About the same capacity as a residential solar panel. Now, what happens is when we charge the battery, the chloride ions stick to the nickel ions. The sodium ions then migrate through the ceramic electrolyte, and it forms a sodium molten anode, self-forming anode. That's why the chemistry doesn't require any copper, cobalt, graphite, or manganese. It's a self-forming anode, and you can see in the cross-section there how that's formed. So that's what happens when it charges. Now when it discharges, it effectively works the other way. And what happens then is that the sodium molten, the sodium ions migrate back through the ceramic electrolyte, they grab hold of the chloride ions, they form sodium chloride again. Now this is the problem that the world is facing and that Altech is providing solution for. This is a typical electricity grid. It's using renewable power. Now we all know solar power is intermittent in its production, and the grid needs power all the time. Now solar and wind around the world are being scaled up. California, for example, wastes $3 billion US per annum in wasted renewable energy that the grid cannot handle. It's been put back into the ground. This problem is exacerbated by EVs coming online, putting additional stress onto the grid. So how do we solve this problem of stabilizing the grid and having power 24/7? The solution is a grid storage battery. This is the future of the electrification of the world. This is what Altech is focused on. Now I mentioned before that Altech's joint venture partner is Fraunhofer in Germany. This project is based in Germany. Fraunhofer has spent the last 8 years, they've spent 35 million euros developing this technology and 25 million euros on the pilot plant facility, proving up. All of the R&D work has been done on this. The R&D risk isn't there. We know this product works. We have 5 and 10 kilowatt battery modules working in the Fraunhofer laboratory. The joint venture now is tasked with scaling up this technology to a commercial quantity. This is some of Fraunhofer's pilot plant facility, sintering the cells at 1600 degrees. We have a finished electrolyte. So how are we, as the joint venture, how are we commercializing this technology? That's a finished 5 kilowatt hour module. That's working, that's tested. So how are we commercializing this technology? Well, Altech already owns 14 hectares of land in the state of Saxony in Germany. This region in Germany has been earmarked as a centre for renewable energy and battery technology, and that's where we'll be putting our plant. This product, this Serenergy battery, is 100% recyclable. It is a complete cradle-to-grave product, and we have the ability on our site to recycle this battery in full. These are the building blocks for our product. These are 60 kilowatt hour batteries, and they contain 240 of these cells. What we do is we then take 18 of those 60 kilowatt hour batteries and we stick them into a standard sea container design. That provides 1 megawatt hour battery capacity, and this is a product that can be pre-assembled on our site, transported to the customer, delivered on the site. It's a plug-and-play design, very simple. With 5 minutes of arriving, the customer can have 1 megawatt hour of power on their site. So we've recently announced the financials for this, and we've recently announced the bankable feasibility study. Now, we had some pleasing economics. We have euro 109 million in revenue. We have an MPV at 9% of 169 million euro. We've got EBITDA of 51 million euros per annum. We have an economic project here for the 120 megawatt hour plant. Based on the back of these financials, the board and also Fraunhofer have decided to move to the funding stage. Now, of course, this product will use state-of-the-art robotics. We need that to produce the cells at 1 every 45 seconds. We have selected some of the best robotics and engineering companies in the world to work on this product. Now, this is some of how the cells are put together. This is alumina, and this is what makes the ceramic electrolyte. They're the ceramic electrolytes being sintered at 1600 degrees. That's the final testing. We rigorously test this product to make sure it's 100% working properly. We have a cell being put inside the stainless steel canister, a 250 watt cell. You'll see here some of the nickel powder and the sodium chloride, the salt being measured and mixed to go into this electrolyte. Some of the final welding to encase the cell. This is all done at Fraunhofer's premises. The cell's being fitted. And then some testing that's being done there. So the first stage of this project is to do the 120 megawatt hour plant. The joint venture and the real vision for this company is to take this technology globally in gigawatt capacities. We have the worldwide rights of manufacturing, licensing, and distribution to do this. It's a very exciting industry. It's growing exponentially, and we're excited to be part of it. We welcome you to join the Altech journey. Thank you very much.
Well done.